Hello everybody, we're in Math 1314. Today we're going to be looking at how to graph polynomial functions. The problem we're going to be looking at involves several steps in graphing a polynomial function. As I go through the steps, I'll read the steps as well as point out important information that will help all of you in developing ideas and eventually graph the function. The first thing we're going to do is we're going to read the problem. For the following function, Part A, use the leading coefficient test to determine the graphs in behavior. Part B, find the x-intercepts, state whether the graph crosses the x-axis or touches the x-axis and turns around at each intercept. Part C, find the y-intercept. Part D, graph the polynomial function. Okay, the first thing we're going to do is let's write our function down. F of x equals 2x squared minus x cubed. All right. Now notice that we do have a polynomial function. Let's look at part A. Part A says, use the leading coefficient test to determine the graphs in behavior. Well, the leading coefficient test involves two parameters. The first one is the leading coefficient itself. And the second component is the highest exponent of the function. Now let's look at our function. Notice how our function is written where the first term actually has a smaller exponent. So make sure when you're looking at the function, look at it very carefully. Find the term that has a variable with the highest exponent. In our case, the second term is the term that has the highest exponent. Now the term that has the highest exponent has n equals to 3, and a sub n, which is the leading coefficient, equals to -1. When we're looking at the leading coefficient test, and I always recommend, please remember when you're learning the theorems themselves, remember to learn the name of the theorem as well, the rule, the theorem, the formula, because it will tell you when you use this particular rule or this particular formula. Okay? Now let's utilize this leading coefficient test, and let's see what happens in our case. In our case, the leading coefficient is negative and is odd. Hence, right end will point down and left end will point up. So now we just answered part A of the problem. Let's look at part B. Let's read the problem. Part B says, find the x-intercepts. State whether the graph crosses the x-axis or touches the x-axis and turns around at each intercept. Remember, when we're trying to find x-intercepts, we always let our function f of x equals to 0. Let's do that. Our function is 2x squared minus x cubed. We'll set it equal to 0. Now we create an equation. To solve this equation, we have to factor the greatest common factor. Here in our problem, the greatest common factor is x squared. Factoring out x squared, we have 2 minus x equals 0. Now that we have our function factored, let's set each factor of the equation to 0. X squared equals 0, 2 minus x equals 0. Notice x squared equals 0. Solve for x. X equals 0. 2 minus x equals 0. Solve for x. We'll subtract 2 from both sides. Negative x equals -2. Divide both sides by -1 and x is a +2. We found two x-intercepts, 0, 0, and 2, 0. But remember, the second part of the problem asks us not only to find the x-intercepts, but also to state what happens at each of the intercepts. This pertains to another rule that we need to remember. It's called rules of multiplicity. Remember, we have two types of multiplicities. Either even root of multiplicity or odd root of multiplicity. If we have an even root of multiplicity, that means that root has to occur even number of times. If we have odd root of multiplicity, that means the root has to occur odd number of times. So let's check our problem. Let's look at 0, 0. How many times that root occurs? The quickest way to figure this out is to go back and look at your factored form of the equation. Look at the x squared. Look at the power on this x. Well, if it's x squared, the power is 2. That power will tell you how many times root occurred. So in our case, root occurred even number of times. So we have even root of multiplicity. Multiplicity of 2. Okay, let's go back to our little rules for multiplicity. If we have an even root of multiplicity, the function at that root will touch and turn. That means it will touch x-axis at that root and then go back where it came from. It will not cross the x-axis. In our problem, at 0, 0, the graph will touch and turn at that root on the x-axis. Let's look at our next root. Our second root was 2, 0. Okay, let's go back to the factored form of the equation. Notice how the exponent here, the power is 1. Well, 1 is an odd number, so we have odd root of multiplicity. Multiplicity of 1. Going back to the rules of multiplicity, if we have an odd root of multiplicity, then the graph will touch and cross. So at our root, 2, 0, the function will touch x-axis, and not only touch it, it will actually cross at that root. Now we've answered part B of the problem. Let's look at part C of the problem. Part C says find the y-intercept. Okay, let's quickly remember. When we're looking for the y-intercept, we will always let x equal to 0. So another way of saying, find out what is f of 0. Let's do that. F of 0, substitute 0 for every x in the problem. 2 times 0 squared minus 0 cubed. Let's simplify, and we will get 0 for the function. This means that when x was 0, y is 0. That's our origin. Okay. Let's look at part D. Part D asks us to graph the polynomial function. Because we do have graphing calculators, let's put all the information together and let's graph the function using the graphing calculator. I will show you how I do that. So now let's look and see how we can graph this function. The very first thing we're going to do is we're going to type in the function into the calculator. So what you see on the screen right now is the plot area. What I'm going to do is I'm going to get out of this screen so I can show you how to get to this plot area. More than likely, when you turn your calculator, you'll see something like this. To plot a graph, we have to click on y equals. This is a plot area where we can type in our function. Remember, our function is 2x squared. Let's start typing in it. 2x squared minus x cubed. Now that we have our function, let's click on graph. Let's look at our graph. Now, if your screen does not show what you see on my screen, there are a few things we can do. You might see your graph very narrow or very, very wide. In that case, you can use the zoom option and zoom in or out. Or you can go to the window. Let me show you what my window looks like so you can recreate the exact same graph. Let's click on window. Now my x min, the lowest x value on the x-axis is -10. It goes to the largest x value, x max, to 10. X scale is 1. Go through and make sure that your x-axis is scaled as such, and look at the y min, y max, and y scale to scale and make sure that your y-axis matches mine. Now click on graph one more time, and you will see the graph. So your graph should look just like mine. Okay. Now, remember what we did in part A. We found out that our right end points down and left points up. Notice looking at your function graphically, look at the right end, it points down. Look at the left end, it points up. Not only that, we also found the x-intercepts in part B. Our x-intercepts were 0, 0, which is the origin. Here it is right here. And then the next one was 2, 0, and we can see it being right here. Okay, now another way of looking at and finding your x-intercepts, we can go to the table. Remember that to find x-intercepts, we let y 0. We let y equal to 0. Go down or up, depending on where you are on your table, and notice when y is 0, x is 0. And when y is 0 here, x is 2. Here they are. Going back to the graph, remember the multiplicity. At 0, 0, we had an even root of multiplicity. And then our function touched and turned. Let's look at the origin. 0, 0. Function went down to the 0, 0, but it looks like it bounced right back off. It never crossed the x-axis. That's touch and turn. Let's look at 2, 0. Now let's keep going according to our function. Get to 2, 0. Notice how it touched, and then instead of bouncing off, it actually went down. It crossed the x-axis. Why? Because we had an odd root of multiplicity at 2, 0. Hence, our function touched and crossed.